Hi, so a system of equations is when we have two or more equations that are working together, and we're trying to find the values that make all of those equations true at the same time. There's a number of ways to do system of equations. This video is going to cover the elimination method. So let's take a look at solving by elimination. We've got these two equations, a system of equations. We're trying to find the x and y that are going to make both of these equations true at the same time. So we're going to take both the equations, and we're going to add them together. So the 2y and the minus 2y is going to get us 0y. 3x and 2x is going to get us 5x. And then if we add the 13 and 2, we'll get 15. So we can get rid of the 0y. And this is the elimination part. So this is why they call it elimination. When we add these two together, the y's get eliminated from the equation. And then we have one equation with one variable, and then we can solve for that variable that way. So 5x equals 15, we can just divide by 5 and get x equals 3. So x equals 3 is part of our solution, but we've got to find the x and the y that make those true. So we're going to take one of these equations. We can take either equation. I'm just going to take the first one. It looks a little easier to work with. We know that x is 3. We've already solved for x. So we can put in x to the equation for 3. Multiply 3 by 3 and get 9. Subtract that from both sides. And we'll get 2y equals 4. Divide both sides by 2. And we get y equals 2. So then we get x equals 3 and y equals 2. That's the x and y values that are going to make both of these equations true, and therefore that's the solution to this system of equations. So let's solve these 5 system of equations using the elimination method. So in the first problem, if we were to add these two equations together, the 6x and 2x is going to get us 8x. The negative 5y and plus 5y, those are going to be eliminated. And the 27 minus 11 gets us 16. Divide both sides by 8. And we get x equals 2. Now to find the y, we can substitute into either one of these equations. Let's just use the first one. So we're going to put x, now that we know x is 2, we're going to put that in for x. 6 times 2 minus 5y equals 27, or 12 minus 5y equals 27. Subtract 12 from both sides, and we get negative 5y equals 15. Divide both sides by negative 5. And you get y equals negative 3. So x equals 2 and y equals 3 are the x and y values that will make both of these equations true at the same time. Now in our next equation, if we were to add these up, nothing's going to be eliminated. The 3x and 3x would get us 6x. The 5y and the minus 3y would get us 2y. So we need to do something a little different with this one. I'm going to do it 2 different ways. So one way to do it is to subtract. So if we subtract for these two, the 3x minus 3x, that will cancel out and get us 0x. So that'll be eliminated if we do subtraction on these two. The only problem is it gets tricky here. We got to watch our signs. So 5y minus a negative 3y is the same as 5y plus 3y, or 8y. The 29 minus a negative 3 is going to be 29 plus 3, or 32. Divide both sides by 8, and we get y equals 4. To get x, we then take one of these equations and substitute y equals 4 in. 3x plus 5y equals 29. Let's just take the first equation, and let's take and put 4 in for y. So 3x plus 5 times 4 equals 29. 3x plus 20 equals 29. Subtract 20 from both sides, and we get 3x equals 9. Divide both sides by 3, and you get x equals 3. So we get x equals 3 and y equals 4 as our solution to this system of equations, which means those two values will make both of these equations true at the same time. Now, if the subtracting negative numbers is a little confusing, another way we can look at this is we can start with the first equation. And what we're going to do on the second equation is we're going to make it so that we can add them and then do elimination by adding. So if we were to take the second equation and change all the signs. Now, how can we change all the signs? Because we can multiply each side of the equation by -1. So if we did that, this becomes negative 3x plus 3y and plus 3. So we just changed all the signs of one of these equations by multiplying through by -1. And then we can do addition rather than subtraction. So these are going to eliminate when we subtract. 5y plus 3y, that's going to get us 8y. 29 plus 3 is 32. And then we can continue the problem on just like we did from here and get y equals 4 and x equals 3. Okay, so on this equation, we can't add to eliminate anything. We can't subtract to eliminate anything. So what we're going to do is we're going to make two things match. So the 4x and minus 2x, we can make those match by multiplying the negative 2x by 2. So what we're going to do is take this whole second equation and multiply both sides by 2. So our first equation we're going to leave the same. We're going to take the second equation and multiply everything through by 2. Basically multiply both sides of the equation by 2. And we're going to get negative 4x plus 6x equals 2. And that's from taking this equation, multiplying it by 2, and we get this equation. Now we're set up to do elimination. So now we can take and add these two equations. These will be eliminated. Oh, we need a y there, not an x. The negative 2y and plus 6y is going to get us 4y equals 12. Divide both sides by 4, and you get y equals 3. Now to get x, we substitute into one of the equations. So 4x minus 2y equals 10. We'll take the first equation, substitute in y equals 3. So 4x equals 2 times 3. Minus 2 times 3 equals 10. That's 4x minus 6 equals 10. Add 6 to both sides, and you get 4x equals 16. Divide by 4, and you get x equals 4. So our answer for this is going to be 4 and 3 are the x and y values that make both of these equations true, and therefore are the solution to this system of equations. Now in this problem it gets even trickier because we can't add the two equations to eliminate anything, we can't subtract the two equations to eliminate anything, and we can't multiply one of them by a constant to be able to eliminate. So what we're going to do is, let's take a look at the x. Let's try to eliminate the x. So we've got 2 and minus 3. So that signs are opposite, so that's all set up for adding. But how can we make these match? We can make these match by multiplying the first equation by 3 and multiplying the second equation by 2. And that's going to make this x be 6x and minus 6x, and then we'll be able to eliminate the x's. So let's go ahead and do that. So the first equation multiplied by 3 is going to get us 6x plus 9y equals 39. And now the second equation multiplied by 2 is going to get us negative 6x plus 10y equals 18. Now we can see that our x's match but are opposite signs. So if we add these two, the x's are going to be eliminated, and we get 19y equals 57. Divide both sides by 19, and you're going to get y equals 3. Now to finish up the problem and solve for x, take one of the equations, either one of the equations. I usually take the one that looks a little easier to work with. So the first one looks a little easier to work with than this. It doesn't have a negative sign in it. The numbers are a little easier. But either one will get you the right answer. So 2x plus 3 times 3, now that we know y equals 3. So 2x plus 9 equals 13. Subtract 9 from both sides. 2x equals 4. Divide both sides by 2, and we get x equals 2. So x equals 2, y equals 3 is the solution to this system of equations. All right, and now the last equation. So we could multiply the first equation by 2, and that way then our x's are going to match up. So let's go ahead and do that. Let's multiply the first equation by 2. So that would get us 4x minus 6y equals 12. This times 2. And then the second equation we're just going to leave the same because that'll make our x's match. And now let's see what happens when we add these both to eliminate the x's. 4x minus 4x gets us 0x, so that gets eliminated. The negative 6y and 6y, that gets eliminated. So 0y. And these are 16. So both things got eliminated, so we get 0 equals 16. So when in a case like this, when both variables get eliminated, if this is not a true statement, 0 does not equal 16, then we say that there is no solution. There are no x and y values that we can pick that would make both of these equations true at the same time. If we had happened to get something that was a true statement here, like if we got 0 equals 0, then we say there's an infinite number of solutions. Thanks for watching. If you have any comments on this video or suggestions for future videos, just comment below. If you'd like to subscribe, you can do so right over here. And I've got another suggestion for you to watch right here. Thank you, and come back again soon.